I hope by now you have a better understanding of different type of load balancer. Let's focus on the last type of load balancer, which is called gateway load balancer. This is very specific use cases, and this can be very useful way of implementing some third-party appliances into AWS. So question come, what are these third-party appliances? Appliances is a common term for any services or network function running on EC2 instances. So maybe some example will enlighten you more. Like I want to have a third-party load balancer. Maybe I am using some third-party load balancer like BalanceNG or Checkpoint or F5 and I want to bring them to cloud. Maybe firewalls are there, third parties, maybe intrusion detection system or intrusion prevention system, some system which can help you to mitigate DDoS attack, distributed denial of service attack, and maybe you have some custom tools you require for visibility, performance monitoring, or analysis of the data which is coming into your application. So that time you would be using these third-party appliances, and there are plethora of services available and partners available who could provide you with this information. I have just pulled up this information about Elastic Load Balancing Partner, and you will find a lot of common names here like security related Chaser, then Checkpoint is there, F5 Network is there, Fortinet, Palo Alto, and so on. You could see lots and lots of third-party vendor offer their solution which we want to deploy in AWS. Before Gateway Load Balancer, what we had to do, we had to deploy this thing on an EC2 machine. That may be a good option, but it may not be a solution which can scale efficiently or which can be implemented very easily. So customers use these third-party appliances for special functions. Maybe their employees already have the skill set required to manage these appliances. Maybe they have operating procedure who revolve around these appliances, or maybe they already bought licenses and they want to keep on using these. So these are why some of the customer may still want to use these appliances. So what challenges they face when they start using this on a standard EC2 deployment? They have fixed throughput and scale. You deploy these software on an EC2 instance. Obviously, a EC2 instance based on the configuration and based on the type you select would have a specific CPU and memory, and you have to take care of scaling and providing the required throughput. This can also become a single point of failure because all the traffic is going through that. This can become difficult to manage and it is error prone configuration. Now customer deploy this EC2 based solution in a different method. One option could be like they configure some tooling so the requests are forwarded to these EC2 instances where the software is running, and after inspection or performing some operation they are forwarded back. So they sit into the path of the request which is coming up, and they have to configure scaling and ensuring high availability. Sometimes customers also deploy that behind set of load balancers. So they may say, okay, I would have a load balancer here, and behind that load balancer I would have group of these appliances to ensure high availability. So that is also possible, but then you have to manage that auto scaling group probably, or maybe the manage the load balancer, and that can be creating a lot of issues. So what we want to solve this problem, and the answer for all these problem is a gateway load balancer. Gateway load balancer uses a specific network virtualization encapsulation which is called Geneve. I'll share you a link about this IETF based protocol standard which is doing a encapsulation of your layer 3 traffic. Now let's see how this gateway load balancer will help us. So we have a source and a destination. Now source could be anything, internal, external, doesn't matter. And now I want this request to be forwarded to a gateway load balancer. So we will create a gateway load balancer, and behind gateway load balancer, we would have third-party appliance fleet, a group of third-party applications running in a fleet which we would be managing. And when my source sends some traffic, that traffic through routing table entries will be forwarded to the gateway load balancer. Everything is happening at the routing layer. Gateway load balancer receives traffic and forward to the healthy appliances behind the scene. those appliances may be performing some inspection, maybe some intrusion detection, maybe tracking something, analyzing something, and once this is done, they would forward this request to the destination. Traffic arrives at destination, it appears to be unchanged, and the response follows the same path in reverse, going back out through the same appliances. So that's what happens when you deploy a gateway load balancer. Now, its name itself is giving me idea that it is performing two things for me. It is a gateway as well as it is a load balancer. So this is a combination of two components within itself. First is a gateway, which is a layer 3 gateway, like you have internet gateway, which you have NAT gateway who forward traffic or receive traffic. Similarly, L3 gateway is there into this gateway load balancer, so you could use that as a next hop into routing table. If you remember, like let's say I added a IGW internet gateway into my VPC. Next, I go to route table and say route table, you would be forwarding any traffic to this IGW. Similarly, we could forward this traffic to a gateway load balancer also because it has a gateway capability. Apart from that, this also has load balancing capability which will be operating at layer 4, and that would allow me to perform scaling, stickiness, health check, flow rerouting, and encapsulation of the original traffic which is coming up. And all is happening because of the support of Geneve protocol. So if you are interested, go ahead and check more detail about Geneve protocol. I'm bringing this information here. So this is a IETF standard protocol, and then this can be accessed. These are like a lot of third-party vendors use this for all encapsulation, so that's what is also being utilized by gateway load balancer. So I hope this thing is clear and you have a better idea on what gateway load balancer is. Let's talk about some more details about this gateway load balancer, how it is implemented. So this architectural diagram which I'm talking about is a very basic and a high level. Actual implementation detail would be a little more complex. So I'll quickly brush up on that and give you additional reference link in case you want to dig more inside it. So let's say this is my consumer VPC where is a source and destination exist. Maybe I deployed my third-party appliances or the services in a separate VPC altogether. I am saying it is a provider VPC because it is providing me some services. So my gateway load balancer exists into a provider VPC. What I need now, I want to forward traffic from my consumer VPC up to gateway load balancer, and for that we would be needing a endpoint. So once I have my gateway load balancer ready, I would be establishing a endpoint which is similar to a VPC interface endpoint, and this will be used as a destination for the traffic coming from source. So source send traffic here through this endpoint, it comes to gateway load balancer. Gateway load balancer will perform the required operation and then forward it back again through routing table entry. So that's what is happening behind the scene. So GWLB include a L3, L4 load balancing capability. GWLBE, which is my load balancer endpoint, it can be the next hop into the routing table, and all this communication is happening on IP layer, which is based on routing table communication. So to get started with it, it is not very different process for the first task. Like what you would be needing, you would be needing a GWLB appliance fleet using steps which are similar to ELB, and afterward you would need to create two components. One is called a endpoint service, which would represent this, and then you have to create this particular endpoint. So a service, and maybe it is an endpoint also you would be creating. It may take a little more complex design, so I'm not going into implementing the second step, but I'll give you some reference architecture so that you could explore them in a little bit more detail. What you will find here that through this I could have created an architecture where I perform centralized inspection with AWS Gateway Load Balancer and a transit gateway. So idea here is, if I look at this diagram, I have deployed my gateway load balancer and I have my appliances running there, and I ensure that every traffic which is going goes through this particular gateway load balancer, and that's how I am able to create an architecture. So this is how I should be able to use reference architecture. Also, this gives you flexibility. Let's say you have your own custom logic to be used before you actually send traffic. You want to process something on your own, maybe something very customizable. So that can also work. Your source can send data to Gateway Load Balancer endpoint. It is then forwarded to the service itself, and afterward your own custom appliances would be utilizing this, and through which you should be able to perform various operations. So it is using Genev protocol. So it is pretty flexible and allows third parties to also start deploying these services. Now, let's quickly go through the process of deploying this particular solution. I would just go ahead and deploy at least a load balancer so that you would know that process of deployment is almost same, and I will then compare all three whatever we discussed so far. So I would go to EC2 and I would select a gateway load balancer deployment this time. So I'm on my load balancer section, and I would be then saying I want to create a load balancer. This is going to be my gateway load balancer. I would say create, and I would follow the wizard, not very complicated. Let me call it GWLB01, and that is my gateway load balancer. I would be selecting the type of IP address that your subnet uses. You could use IPv4 or dual stack. Network mapping, I have the similar VPC project VPC which I want to map into. Once I mapped it, I would need a subnet where it would be keeping its anchor point, so I could keep it in any of them. So let's say I'm keeping it in private 1, and the second one is I'm keeping into private 2. That is no problem at all. Similar stuff we have done before also. This is done. Now I could create listening configuration. Now this is an IP listener, right? This operates at layer 3 of the OSI model. So all traffic will be received by a single listener and routed per your specification. So I don't have to select port number because that would be a layer 4 information. Here all of the traffic would be forwarded, and I would be creating a target group for it. I do not have any third-party appliances in my account as of now, so I would still create a target group, keep it blank, and maybe in future I could add those third-party appliances into my architecture. So I'm creating it for instances. Let me call it GWLB TG target group, and here is the protocol selection. You could select what kind of protocol you want to use. I'm keeping it Genev. I'm keeping it into project VPC, health check, again TCP, HTTP, HTTPS options are there, and I can then add targets in that. So I don't have any target as of now. I haven't deployed any EC2 instances with custom software on that. So I would keep it blank and still just create a target group. So I have a target group which I would use as a destination, but behind the scene there is nothing inside the target group. So that is completely fine for a demo purpose. So I now go back, refresh the screen, and my my target group should be displayed here. That is same which we have done before, and I would then start going ahead with the summary of that. I would go ahead and say okay, done, create a load balancer. So that process is same, but what else you have to do afterward, I will just briefly talk about that and you can explore it more. Once this is done, you would be needing a VPC endpoint service to be created. So we'll go to a VPC section and follow the reference document I would be sharing into the resources section. So first you would be creating an endpoint service. And once this endpoint service gets ready, you would create endpoint, which will be your interfaces on specific subnet in AZs so that you could reach out to the service you have just deployed. So it's like you are deploying a service and allowing others to communicate to that service by using endpoint on that. So I hope this is clear. You would be creating endpoint service first, and then you would be creating corresponding endpoint for your application. So check that reference architecture. I hope this basic idea is clear with you. Now let me summarize this discussion by comparing all three. We did comparison of ALB and NLB before, but let's now compare GWLB also along with both of them. So application load balancer operates at layer 7, network load balancer at layer 3, and my gateway load balancer, it has layer 3 functionality for gateway and layer 4 functionality as a load balancer. Decision to route traffic is content of the packet. Here again, header of the packet for network load balancer. Hopefully you remember the example I gave you for king and secretary. And here it is header of the packet, or basically everything is forwarded because we are just forwarding all the requests coming up. So that is still reading the header of the packet. What next? Supported protocol are HTTP, HTTPS, gRPC, in network load balancer, TCP, UDP, and TLS, and gateway load balancer is just using IP-based forwarding. When it comes to static and elastic IPs, application load balancer do not have static and elastic IP associated. Network load balancer allow it. Gateway load balancer won't need it because it would be associating with the endpoint services you would be connecting to. So it will not be needing any static and elastic IP. It would be always functioning by the route table entry you would be creating. Then last point here, target types. Application load balancer support instances, containers, Lambda IP addresses. Network load balancer apart from Lambda everything, but for gateway load balancer I would be able to use instances and IP addresses. So I hope this thing is clear. Now container support is also there. We have added Kubernetes support, but I was not 100% sure. That's why I haven't added it. But container support is also there with gateway load balancers. So I hope this thing is clear and you have a better idea on how all these three type of load balancers are there. So we talked about elasticity. We took a tangent and talked about elastic load balancing. Now what we'll do in the next section, we will combine these load balancer and create a auto scaling group so that we can deploy a full auto scale application in our environment. So I hope you are enjoying. I'll see you into the next section. Thank you.